In this video, I'll discuss how to recognize archived and compressed files. Linux has multiple archiving tools that can be used to store a group of files or directories of files in a single archive file. Traditionally, archiving tools were used for making tape backups, but these days archiver commands in Linux can write the output to a file instead of a tape device. Archived files are usually compressed, but they don't have to be. There are many different compression mechanisms that can be used when creating an archive of files. tar is the most commonly used archiver for Linux. It has options whereby we can also compress the files that we're adding to the archive. Star is a faster version of tar. It's got support for advanced options like file system access control lists. It also supports longer file names. The AR file archiving command is an older tool that's been deprecated in the Linux standard base, but it is occasionally used in software development environments. File compression comes in many forms in Linux. We can use the gzip along with the gunzip tools, bzip, xzed, rar, arj, 7zip, and so on. We don't have to use compression and decompression when we archive files. They can be used unto themselves to save disk space. For example, we could use the gzip command to specify one or more file names that we wish to compress. We could then use gzip-d along with the file name to decompress it. We have the same type of options available for other types of compression utilities like bzip2, xzed, and so on. If we're using a combination of tar, the tape archiving tool, along with compression, we would see that at the tar command line, if we use the -z, we're telling it that we want to use gzip to compress the tar file. In the same way, when we extract the archive, we would use the Z in the command line switches again to tell it that it's been compressed with gzip. In this video, we discussed how to recognize archived and compressed files. In this video, I'll demonstrate how to use gzip to compress files and how to use gunzip to decompress files. Here on my Linux system, I'll type ls to view the contents of the user files directory, where I can see we have a file called phone call log. To display the contents of the phone call log, I'll use the cat command. So I'll type cat space phone call log. We can see it's just a standard text file with some log entries about phone calls that were made on certain dates. I'm going to clear the screen, and this time I'll type ls-l space phone call log because I want to see the approximate size on disk that this file is occupying, and that shows up as being 249. Now I'm going to compress that file with gzip, so I'll type gzip space phone call log and I'll press enter. If I do an ls-l of that file, notice it tells me there's no such file or directory. And that's because when you use gzip to compress files, it automatically adds a .gz file extension. So the original file is no longer there in its original form. Instead, it's stored now in compressed form. If I type ls-l phonecalllog.gz, we can now see that the file size has been reduced from 249 to 203. And if I try to use the cat command to display the contents of that file, it will no longer work because it's not just a text file. It's been compressed with gzip. I can decompress the file using the gunzip command. So I'll type gunzip space, and then I put in the name of my compressed file, which in this case is phonecalllog.gz. So now if I type ls, we're back to having our original uncompressed file called phonecalllog. And of course, I can work with it using the cat command to display its contents because it's just a text file now. It's no longer compressed. I'm going to change directory to the scripts folder, where if I type ls, we can see we have a number of script files that end with .sh. I want to compress all of them with a single command. So I'll type gzip space *.sh. Now if I type ls, notice that a .gz file extension was added to each of them. So each of those files was compressed, but with a single command. In the same way, I could decompress them or unzip them by typing gunzip space *.gz. Now if I type ls, we're back to having our original script files. In this video, we learned how to use gzip and gunzip to compress and decompress files. In this video, I'll demonstrate how to use bzip2 to compress and decompress files. On my Linux system, I'll type ls to view the contents of the scripts directory. Here we see a number of script files. If I type ls-l, we also get to see their sizes. bzip2 is used to compress files to save space. One way to use bzip2 is to type in bzip2 space *, which will compress every file in the current subdirectory. When I type ls-l this time, we notice that each file has been replaced with a compressed version of itself. bzip2 adds a .bz2 file extension to indicate that the files have been compressed, and if we take a look at the size column, in fact, we can see it looks a little bit different. So we've saved a little bit of space by compressing using bzip2. I can use the bzip2 command with -d to decompress files. Here I'll type in an asterisk after the -d to decompress everything in the current subdirectory. So I'll clear the screen and type ls-l, and now we can see the files have been returned to their original state and their original sizes. I'm going to recompress them again, but this time I'm going to type bzip2-v for verbose and -9. And I'm also going to specify that I only want to compress files that end with .sh. -v means verbose. It will give me detail about compression statistics for each file that gets compressed. The -9 tries the best possible compression. Now it may take a little longer, but we'll end up with a smaller file size in some cases. And of course, I'm telling it only to compress files that have an sh file extension. When I press enter, I can see because of the -v or verbose that I was given more information as the compression was occurring. If I type ls-l, we can see the files are compressed, and they again have had the bz2 file extension added. Another way to decompress instead of using bzip2-d is to use the bunzip2 command. Here, I'll type bunzip2 space *.bz2. Now when I type ls, we can see we've returned our compressed files to their original decompressed state. In this video, we learned how to use bzip2 to compress and to decompress files. In this video, I'll demonstrate how to use the tape archiver command. The tape archiver command in Unix and Linux comes in the form of a command called tar, spelled T-A-R. Even though the name implies backing up to magnetic tape, we can create an archive of many files to a single file and store it on any type of storage media. Here on my system, I'm going to type ls-R to do a recursive listing of files in and under the user files directory. So we can see there are a number of files and subdirectories with content, and my goal is to archive all of this to a single file in my /backup directory. To do that, I'll start with the tar command. Then I'll type -cvf, where the C means to create an archive, the V means I want verbose output as it's being created, and the F lets me specify the path and name of the archive file. For that, I'll specify a name of userfiles.tar. Finally, as the last parameter, I have to give it the source. So I'll tell it /userfiles. The tar command is recursive by nature, so it's going to archive everything in and under the /userfiles directory. Because of the -v, I see the verbose output is showing me everything that was placed within the archive. I'll type ls-l where we can see our userfiles.tar file. I'm going to run the same command but with one variation. I'm going to add a -z. So tar-cvzf. We know that the C means to create an archive, V is verbose, and F lets me specify the archive file name, but the -Z means that we want to compress it using gzip compression. So this time I'm going to name the file userfiles.tar.gz to imply that it's been compressed with gzip. Of course, the last parameter once again must be the source that we wish to archive, which will be /userfiles. Now this time if I type ls-l here in the backup directory, I can see both archive files. The first is not compressed and the second is. Notice that the compressed file is consuming less disk space. We also have the option of viewing a list of entries that were archived within an archive file. To do this, I can type tar -t vf. The T allows me to view what's in the archive, V is verbose, and F lets me specify the file. Here I'll type userfiles.tar. And when I press enter, I can see a listing of all of the files that were archived in that single file. Notice that when we archive files, it also retains the metadata about the file, like the permission sets, as well as file ownership. I'll type clear to clear the screen. I'm going to make a directory in the current location called tmp. What I'd like to do is move my compressed userfiles.tar.gz file to that tmp folder. The reason is because I'm going to change directory into the tmp folder so that we can decompress our archive. So we might have done this for backup purposes, and in the event of a problem, we might decide to decompress the archive to put some files back that were either deleted or corrupted. So to perform the decompression, what I'll do is type tar -ZXVF. The Z means it's compressed. The X means I want to do an extraction. I don't want to create an archive. I want to extract files from an existing one. The V means verbose, and F, of course, means I'll specify the file. Now, the order of these letters on the command line with tar don't matter other than the -F. What must immediately follow the F is a space and then the path and name of the archive file. But other than that one, you can move the other command line parameters for tar around and it won't make a difference. So here I'm going to tell it the name of my file is userfiles.tar.gz. When I press enter, because of the -V for verbose, I can see it's telling me everything that was unarchived from that file. If I type clear and then ls, we can see that it's recreated the subdirectory structure from our original source here in this location. So I'll type ls-R user files to make sure that it brought everything back from our archive. And in fact, we can see that it has. In this video, we learned how to use the tape archiver command. In this video, I'll demonstrate how to use the extended tape archiver command in Linux. The extended tape archiver command is called star, and it might not be installed in some Unix and Linux distributions, so you can install that package and then you can use the star command at the command line. Here on my Linux system, I've typed ls to view the contents of the scripts directory. And here I see a number of files that end with .sh. We're going to store those in an archive, and we're going to create the archive using the star command. So my command will be star space -c to create the archive, -v for verbose output as it's creating the archive, and then -f equals, where I then specify the path and name of my archive file. Here, the path will be /backup and the file in that directory will be called scripts.star. The last parameter is the source. What is it that we're trying to archive? So I'm going to type in star.sh. When I press enter, we can see the verbose output shows me which files were added to the archive. And if I type ls/backup, we can see that we've got our scripts.star file there. We can also use the star command to view the list of files that have been archived. To do that, we could type star space -t -v -f equals, and then I'm going to put in /backup/scripts.star. So we haven't unarchived anything. We're simply getting a list of the files within the archive. We can also see the permission metadata as well as the ownership metadata for each file was retained when it was archived using the star command. I'm going to change directory to the backup folder on my Linux system where I'll type ls. Here I'm going to make a copy using the cp command of the scripts.star file, and I'm going to copy that to the temp folder tmp. I'm going to change directory to tmp and then ls. Here we've got our star archive file. We're going to extract it using the star command. So my command will be star-x to do an extraction, -f equals, and in this case the file is in the current directory and it's called scripts.star. When I press enter, it completes the extraction, and if I type ls, I can now see that I've unarchived or extracted my 4 shell scripts from the scripts.star file. In this video, we learned how to use the extended tape archiver Linux command. In this video, I'll demonstrate how to use compression with the tape archiver command. The first thing we'll do on our Linux system is type ls-R to do a recursive listing of everything in and under the user files directory. So we can see there are a number of files and subdirectories containing files. We'll start by building an archive of this content, and then we'll build a second archive that's compressed and look at the difference in size. To build our first archive, we'll type tar -cvf, where C will create the archive, V will give me verbose output as it creates it, and F will allow me to specify a path and file name of the archive, which will be /backup/userfiles.tar. The last parameter is the source that I wish to archive, and what that will be is /userfiles. Now if I clear the screen and type ls here in the backup directory, I can see I have a file called userfiles.tar. I'm going to create an archive of the same source files again, except the difference this time is that it will be compressed. So my command will be tar-cvzf. What's different here is the -z, which means we're going to compress our archive using gzip compression. I'm going to tell it that I want to create the archive under /backup, and it will be called userfiles.tar.gz. The gz simply implies it's been compressed with gzip. My source will be /userfiles. I'll clear the screen again, and I'll type ls-l here in the backup directory. Notice that the compressed version of our archive file is notably smaller than the uncompressed version. The compression occurred when we used the -z as a command line switch with the tar command. If we wish to decompress, we could use the tar command with -xvzf. The X means we want to do an extraction. Of course, we tell it the name of the file, which in this case would be userfiles.tar.gz. It will extract it in the current location. So if I press enter and then type ls, we can see it's recreated the user files directory. So I'll type ls-r user files, and we can see everything was extracted to this location. In this video, we learned how to use compression with the tar command. In this video, I'll demonstrate how to use the Linux zip compression command. Here on my Linux system, I'm currently in the user files directory. I'm going to type ls-budgets to view the contents of the budgets directory, and we can see that it contains a number of budget files. I'm going to use the zip command to create a compressed archive of all of these budget files. I'm going to type in zip -r. The lowercase r means recursive. So not only will it look in the budgets directory, but in any subdirectories under that location. The next parameter is the location of my zip file. I'm going to store it in /backup, and it will be called budgets.zip. Then, as the next parameter, I have to tell it what it is that I want to archive and compress. So here I'll simply type in the name of my folder, budgets. When I press enter, it tells me that it stored all of those files in the budgets directory into my archive file. And as a matter of fact, if I type ls/backup, indeed we can see there is a file there called budgets.zip. I'm going to change to the backup directory, so I'll type cd/backup. I'll clear the screen with the clear command and once again type ls. Now, what goes hand in hand with the zip command is the unzip command. What I want to do is use the unzip command to list the contents within that zip file without extracting the files. So my command will be unzip space dash lowercase l space slash backup slash budgets dot zip. I have to tell it the name of the file whose contents I wish to list. So it's showing me all of the budget files stored within the budgets.zip archive. And at the bottom, it says there are 17 files. There's some good stuff I can do here, such as I can delete or add files to or from the zip. For example, what I want to do is remove all of the budget 2011 files from the zip. I don't want them included any longer. So what I could do using the zip command is I could type zip space dash lowercase d for delete. In this case, the subject is budgets.zip, and then I'll put in perhaps asterisk 2011 asterisk. So I'm using wildcards. Any file names that have 2011 I want deleted from the budgets.zip file. So I'll press enter. And it tells me that it's deleted a number of files. I'm going to clear the screen and I'll use my up arrow key again back to the unzip-l command where we can list the contents of the zip. Notice there are no longer any 2011 files. And instead of it telling me that I have 17 files in the zip, it now says I only have 13. I'm going to copy the budgets.zip file to a temporary directory. Here in the temporary directory, there is nothing but the file that we've just copied here. I've copied it here so we can unzip it in this location. So I'll type unzip space budgets.zip. And if we type ls, you can see that it will have recreated the subdirectory structure along with all the files that were compressed and archived. Interestingly, we can also work with compressed files from the GUI environment. Here on my desktop, I'm going to go into my home folder where on the left-hand navigator, I'll click computer and I'll go to the backup directory on the root of the file system. And here I can see my budgets.zip file. If I right-click on the budgets.zip file, I have a number of options such as opening with Archive Manager, which will show me what is inside that zipped archive without actually extracting it. Although I could extract all files, or I could even right-click on a single file to extract it. I'll close that screen for Archive Manager. If I right-click on the zip file again, notice I have other options such as extracting here and so on. So we can work with compressed files in the graphical interface as well as from the command line. In this video, we learned how to use the Linux zip command. This exercise focuses primarily on working with bash scripts. Specifically, in this exercise, you'll begin by using the output redirection symbol to put the word hello into a new text file. You'll then use the VI text editor to edit that file and add the word world. You'll then create a bash script that will tar the file that you created. Then you need to change to the root directory and use the find command to locate your script to execute it. Finally, you'll update your bash script to compress the tar file, and then you'll run your script in the background. At this point, pause the video and try out these exercise tasks. Then come back to the video to see one potential solution to each of the steps. Okay, here's one way to deal with each of the exercise tasks. The first task asked us to use output redirection to put the word hello into a text file. We can do that using the echo command with the output redirection symbol. And I'm going to store that in a file that I'm going to call data file. If I use cat against data file, I can see it currently contains the word hello. We were then asked to use the VI command line tool so that we could edit the file and add the word world. So I'll type VI data file, I'll press insert, and I'll just move over and add the word world. Then I'll press escape, and I'll type :WQ for write and quit. And if I cat that data file, it now contains hello world. We were then asked to create a script that would tar our file. So I'm going to use the VI command to create a script called script.sh. I'll press insert, and the first thing that should be in every script is the shebang line. In this case, $!bin/bash. Then I'll use the tar command with -c to create an archive, and F, where I'll then specify the archive file name in /backup data.tar. Then I'll tell it I want to archive a file in /user files under /scripts, and that file is called data file. To save the script, I'll press escape, I'll type :WQ. But the problem is, if I type ls-l, our script hasn't been flagged as executable, and it needs to be for someone to run the script. To flag it as executable, I could type chmod +x script.sh. And if I run ls-l again, well, we can see clearly that the script is now flagged as executable. The next thing we were asked to do in our exercise steps was to change to the root directory. So I'll do that with cd /. We were then asked to use the find command so that we could locate our script. So my command is find -name and in quotes script.sh. The find command located two occurrences of this file name. It's the second one that we want. So I could actually execute my script by putting in the full path and file name. So I'll type /user files /scripts/script.sh, and I'll press enter. To verify the script ran, I'll just type ls/backup to see if there's a file there called data.tar, and in fact, there is. The last step of the exercise asked us first to update our script to compress the tar file and then to run the script in the background. Well, let's deal with one thing at a time. I'm going to go into the /user files /scripts directory, where I'll type vi script.sh so we can make a change to it. I'll press insert, and I'll change my tar command by adding the -z command line parameter. What this does is it uses gzip to compress the archive. I'm also going to make sure that the new file has a .tar.gz file extension to imply that it was compressed. Then I'll press escape and :WQ. Now to run that script in the background, and I'm in the current directory with it right now, I could type /, and then after that I'll type in the name of my script, script.sh, and I'll follow that with an ampersand to run it in the background. I notice that it's been given background job number 1, and I can see the process identifier of 6890. If I type ls/backup, we can see now there is a file there called data.tar.gz. In this exercise, we learned how to work with bash scripts.